Hello, my name is Punit Patel, and today I'm gonna present you my app project 2. My group number is B07-7, and my UC ID is 300064251. So as you can see here, this is my main file, and inside my main file, I've defined the macros for idle and sleep mode. After that, this is my main function, in which we have initialized the clock to 32,000 hertz. After that, we have initialized UR2 module, which was defined in UR2.c, which was given by Professor Vyas. After that, I'm calling IOInit function. This function is defined in iOS C. Uh, as you can see here, what this function does is it makes all the analog pins as digital and sets all the pins with their respective inputs or outputs. After that, I'm putting the MCU in idle, and the rest of the work is done inside my iOS C file. In here, I've defined a function called IOCheck, which checks for the interrupts on the switches, switch 1, switch 3, and switch 2. These interrupts are controlled over here. Inside my IOCheck function, first I'm checking if switch 1 is pressed. If switch 1 is pressed and check PB1 is 0, check PB1 and check PB2 are actually my flags to check for interrupts. Then turn check PB1 to 1. Otherwise, run a while loop. Inside a while loop, I'm selecting mode 0. This mode select is used while doing ADC. So when the do ADC function is called with mode select, then inside the ADC file, ADC.c file, thus mode is passed, and thus mode is used to set the pins right here. So mode 0 is for pin number AN5, and mode 1 is AN11. So when switch 1 is pressed, mode 0 is selected and ADC is done at AN5. The voltage is where the ADC's result is stored, and after that it is multiplied by VRES. VRES is the voltage of reference. I've defined VRES at the start of the file, which is right here, 3.13. As you can see, VRES is reference volt upon 1023, which should be equal to 3.13 millivolts. But just for the sake of calculations, we are using 3.13 and then dividing it by 1000 wherever needed. So after that, I'm updating the clock speed to 8 megahertz and displaying the functions. In here, as you can see, I've declared two other variables before and after. This was done to make sure that the voltage is displayed as a decimal number instead of a single number or a string. So before stores the value before the decimal, and after stores the value of the voltage after decimal, and those both are separated by a dot. Similarly, if switch 2 is pressed, then I'm checking for the flag of check PB2, and if else, inside that if else while loop, we are checking for the resistance. So when we are checking for the resistance, or when switch 2 is pressed, we are selecting mode as 1, so the pin AN11 will be activated while doing ADC, and the results of ADC are stored inside this variable called resistance. The output is calculated similarly as before, from the voltage resistance, which is the output of the ADC, multiplied by voltage reference divided by 1000. After that, we are using a formula to find resistance, which is output, which we got it from here, multiplied by 1000 divided by voltage given, which is our source volt, minus the voltage of input, which is our output, which is stored in here. So this res variable stores our resistance values, and after that we are displaying the resistance values as before. Now let me show you my breadboard. So this is my breadboard, and this is a potentiometer. The blue device is potentiometer, which will be used to calculate resistance and voltage simultaneously. We will change the connections, and let me pull up Terraterm, build the project. Okay, now this is my switch 1, switch 3, and switch 2. Let me show you by pressing switch 2 first. As you can see, ohm meter resistance is displayed. Now if I try to increase the resistance value on my potentiometer, just give me a moment, and as you can see, the voltage is resistance is increasing. I've used 10,000 ohms potentiometer, so the maximum amount I'm getting is 10,800. Now if I press switch 3, this puts the the MCU in idle, which means the resistance won't be updated anymore. There. Now let me move the potentiometer from resistance to check out our voltage. So I've changed the potentiometer's position, and let us press switch 1, and here you can see it displays voltage. I'm gonna increase my potentiometer a bit by bit. There. As you can see, I'm getting maximum voltage of 3.33 while I have passed maximum voltage of 3.3. So the output voltage is within the error limits. And let me just show you one more time. If I press switch 3, it puts the MCU in idle. Thank you.